In this screencast, we're going to focus on the binormal vector and torsion. When you calculate t and n, the cross product of those two vectors is b. Because t is 1 long and n is 1 long, the parallelogram formed by t and n happens to have an area equal to 1, which means the length of b is 1. So all of these vectors are unit vectors. Remember the formula b is t cross n. If you reverse the order and you do n cross t, you don't get b anymore. Instead, you get negative b. So order actually matters here. And one way to see it if you cross n and b, you get t, is if I'm going to take this finger, which is the first vector in a cross product, I'm going to point that in the n direction. And then if I take this finger, which is the second finger in a cross product, and point that in the t direction, notice that my thumb points n, or I guess so if that's n and t is the vector coming out, then b is not going up as it should be. But if I take t and cross it with n, then b points up as it should be in this picture here. Since b is 1 unit long, we know some things about b. In particular, since the magnitude of b is 1, the derivative of b with respect to s happens to be it's orthogonal to b itself. So if I calculate the derivative of b with respect to s, I get a vector which is orthogonal to b. It can't point down, it can't point up, it has to be in the plane orthogonal to b. We're also going to show that it has to be orthogonal to t, that dB ds is orthogonal to t, which means that the vector has to either point against n or with n. And so what we're going to find is that dB ds is parallel or anti-parallel to n. How we're going to do that right now is we're going to show this by actually taking a derivative. We're actually going to use the product rule on the cross product. So if you take the derivative with respect to s of b, I'm going to rewrite b as b is t cross n. So if I take the derivative, this is a product, it's a cross product, so the derivative of a product requires the product rule. The first times the derivative of the second plus the derivative of the first times, and the times in this case is a cross product, times the second. Now one of these vectors, in particular this one right here, is a vector we know. It's the curvature vector. But the curvature vector and the normal vector point in the exact same direction. So the curvature vector and the normal vector are in the same direction. The parallelogram formed by them has 0 area, which means this product right here is the 0 vector, which means that dB ds is t cross d and ds, which means that dB ds and t are orthogonal, because when you cross two vectors, you get a vector which is orthogonal to both. So dB ds and t are orthogonal. So what we have is that dB ds is orthogonal to b, and dB ds is orthogonal to t, which implies dB ds has to be parallel to n. So these two facts show it's parallel to n. Torsion is the length of the vector dB ds, and it's got a plus or minus. To determine whether it's a plus or minus, you have to make the choice. If your t vector comes in that direction and n points to the right, b heads up, and your dB ds is pointing opposite n, then we say that torsion is positive. Whereas, if I calculate t, n, and b, and dB ds points to the right, or points with n, then I say that torsion is negative. This can be seen by, if this is my t and b frame, and my vector points in that direction, I'm going to grab a second right hand. So take your left hand, put your thumb on the right hand side, or point opposite. So this is essentially a second right hand. Now, if you move in the direction of motion, so if we're moving against t, then when I wrap around, notice that my thumb ends up pointing in the direction of motion, which is why we say that the torsion is positive. When dB ds points opposite n, torsion is positive. If it points with n and I'm moving in this direction, So as I move around in this direction, then when I wrap around, notice that my thumb is now pointing against the direction of motion. It's kind of hard to see in the camera, which is why we say that torsion is negative. That completes this.